solving inverse trig equations. So what if we wanted to solve an equation that has an inverse trig function in it? The good news is this is not complicated. We can just follow normal algebra steps here. First thing I should do is subtract pi from both sides, and then it looks like I can divide by 3. Now let's see, is this a valid equation? Can the sine inverse function throw out an angle of pi over 3? Absolutely. Sine inverse knows about angles between negative pi over 2 and pi over 2. How can we think of this equation? This is saying the angle whose sine ratio is 2x is equal to pi over 3. Well, since the sine inverse function is a restricted function, I know there's only going to be one answer here. I can undo it by simply using the sine function. In other words, I can take the sine of each side. Why haven't we been doing something like that with the regular trig equations? Well, because the regular trig functions are periodic. There's multiple solutions. But the sine inverse function is restricted, so I'm safe. What I have here, the left becomes just 2x. Sine and sine inverse have wiped each other out. And on the right, I have sine of pi over 3. Do you see that this line says the exact same thing as the last line did? The last line said that the angle whose sine ratio is 2x is pi over 3. Well, that's all we've written down. Apparently, if you stick pi over 3 into the sine function, you get 2x. Well, sine pi over 3 is something I can work out. It's one of our basic values. You probably know it off the top of your head. If not, you can quickly draw yourself a 30, 60, 90 triangle. Pi over 3 is just 60 degrees. You can fill that in very quickly. And we know that the sine ratio is opposite over hypotenuse, so that would be square root of 3 over 2. Well, I'm almost done. To get x by itself, I would just divide both sides by 2, or perhaps it would be simpler to just multiply both sides by 1/2. And I end up here with x equals square root of 3 over 4. And that's it. That's the one value of x that makes this equation true. Thanks for watching.